The last example we're going to talk about in section 2.5 is to find a second derivative. So I'm going to start with this x squared plus y squared equals 25. All right. You may recognize that as a circle centered at 0, 0 with a radius of 5. And I want to talk a little bit about notation first. Some different notations for the second derivative might look like this. We have f double prime or y double prime. We might have f double prime of x. Right. There's another notation that we frequently use as well, though. We know that d dx means the first derivative. So the second derivative is indicated as d squared of something over dx squared. So this is the second derivative of something, and it means that. So we could have d squared y over dx squared. That's the second derivative of y. Or we could even write it this way: the second derivative, d squared dx squared of y. So those are just some different ways you'll see it. Typically the second derivative of y is going to be written this way: d squared y over dx squared. Alright, so as we work through this problem now, first step is to find the first derivative. So I do that implicitly. I use the chain rule on the y squared term. So I have 2x plus 2y dy dx, and then the derivative of 25, any constant, is 0. And then I just have to solve for dy dx. So I'm going to subtract the 2x and then divide by 2y. And when I do that, I get a negative x over y as my first derivative. Alright, so to find the second derivative, I'm going to take the derivative of the first derivative. Right. So I want to take the derivative of, when I find the second derivative of y, I want to take the derivative of what I found the first derivative to be. That's negative x over y. So I'm going to pull this negative sign out and take the derivative of just x over y. So I'll still have that negative sign there, but I don't have to worry about that as I carry it through the calculations. All right, so I'm going to have to use the quotient rule on this, in addition to being careful about using chain rule for the y. Well, I don't really have to use the chain rule because it's just y. It's not y squared or y cubed. So I use the quotient rule there. So the derivative of the numerator is 1 times the denominator minus the derivative of the denominator, which is dy dx, times the numerator, all over the denominator squared. And I still have that negative sign there. I'm carrying that down from there.
Students, all textbooks, back order textbooks are in, or back order textbooks are in. Please go by the lecture hall and pick your books up. And please go by the lecture hall, pick your back order books up. Following students have a message in the front office: Bevan Means, Sierra Agrella, Colin McCarley, Rachel Casey, Tristan Prukop, Haley Harrison, Dakota McGovern, and Marissa Coleman. Thank you.
Okay, sorry about that. So we're here. We've used the quotient rule, and I still have that negative sign. I have to be careful not to forget about that. Now what I'm going to do here is I want this second derivative just in terms of x and y. Right now I have it in terms of x, y, and dy dx. So I'm going to substitute in, this is just the first derivative, dy dx. And I know that that first derivative is negative x over y. So I'm going to replace the dy dx with the negative x over y. Alright, so that dy dx is replaced with what the first derivative actually is, which is negative x over y. And now I can see that I have these negative signs. They're gonna cancel out, and I have x squared over y. So my second derivative now looks like this. And I'd just like to clean this up a little bit. I really don't like having a fraction within a fraction. So I'm going to multiply through by that y. Let me show you what I'm doing here. I'm going to multiply through by y over y. Now when I distribute the y here, I get a y squared. When I distribute it here, I'm going to cancel this y out, and I just end up with y squared plus x squared. In the denominator, that y multiplies by the y squared that was already there, and I have y cubed.
All students, back order textbooks are in. Please go to the lecture hall. Please go to the lecture hall if you need a back order book. Also, the following students need to come to the front office to pick up an item: Beverly Means, Sierra Agrella, Colin McCarley, Rachel Casey, Tristan Prukop, Haley Harrison, Dakota McGovern, and Marissa Coleman. Thank you.
Okay, we're almost there. Hang in there. We have our second derivative in terms of x and y. Okay, we can simplify this a little bit more if we recall the original equation told us that x squared plus y squared equal 25. So I'm going to replace this y squared plus x squared with a 25, and then the simplest form I can get that second derivative in is negative 25 over y cubed, which is nice because now it only is in terms of y and I've eliminated the x variable.